Good day to everyone. So in the last video, we have seen the iterative loops as well as the while loops and how to use the cycle and exit statements in your corresponding iterative and the do while loops. So in this video, I'm going to give the information about the thought about the named while and do loops. So it is also possible to assign the name to the loop, suppose as like the branches if and else control constructs. So the general form of the while loop as given attached here. So you can start the while loop with the do, that means with a particular name. Then the statement whatever the statement you can execute, and you can also check multiple conditions. Then you can stop the loop with the end do with the particular name. So whatever the name you have stated in the starting with the name in the do loop, that should be ended with the same name. There should not be any name mismatch. So similarly, so as usual, the name may be a 31 alphanumeric characters long, as well as the beginning with the letter. The name given to the loop must be unique within the program unit. This already explained. I already explained in the control constructs itself. So if a name is assigned to a loop, then the same name must appear in the associated end do. So similarly, the names are optional in the cycle and exit statements associated with the loop, but if they are used, then they must be the same as the name on the do statement itself. Again, the same question is again coming, the why the naming the loop, the naming the statements is the same answer. It is for the troubleshooting purpose. Suppose if you have some more than 100 lines or a complex program, very complicated program, then mentioning the name will help the user as well as the compiler to do the troubleshoot easily. So you can also use the nested loops. For example, like a nested if statement, one can also use the nested loops. So yeah, one loop is completely inside the another loop. Then the two loops are called the nested loops, and this is the corresponding example for the nested loop. So you have two different do loops in the same program, and so the do loops is actually opened, and you can do some operation, and you can properly end the two loops with the end do statement. So in this example, the do loop will assign a value 1 to the index I first, and then the inner do loop will be executed. The inner do loop will be executed 3 times with the index variable j, which is equal to 1, 2, 3. When the entire inner loop, the j loop is executed completed, then the outer loop will be assigned the value is 2 with us to for the variable I, and then the inner loop again executed again for 3 times. So this process repeats until the outer do loop will execute the last time, that is the last third time. Then the corresponding result will be printed here. So what I have done is I have just multiplied the value of I and j and I store the value in the product, and then I just return the corresponding value. The first time the value of the outermost loop is taken as a 1, the I value is 1, and j value is incremented by 1, 2, 3. For all the 3 times, the value of I is equal to 1. So this is I, and this is j, and this is product. So once if it reach the maximum value, then the count of the I will be executed, incremented by 1. So for the 2, again the j value is written for the 3 times. Similarly, after the j, the inner loop reached the end in the last value, it again the I value is incremented to 3. Again the multiplication is worked. So this is the corresponding output for the program. So if you note the program, the inner loop executes completely before the index variable of the outer loop is incremented. Suppose if you use the suppose when the Fortran compiler encounters the end do statement, it associates that end do statement with the innermost currently opened loop. Therefore, the first end do statement above closes the j equal to 3, and the second end do statement above closes the do I equal to 1, 2, 3 loop. So this is for the outer loop. So this fact can produce hard to find errors. Suppose if you are not giving the names to the corresponding loops, so it is always recommended to use the if you to give the name for the corresponding loop. Suppose if you are using the nested do loops or if loops, so that the error will be much easier to find. Okay, so one can also use the cycle and the exit statement in your nested loops. The named loops. Suppose if you are not naming the do loop, but suppose if you are using the cycle statement, cycle or exit statement, then the innermost loop in which it appears is actually mentioned, repeats itself. The cycle statement will execute the innermost do loop, and then it actually considers this. It actually operates the corresponding operations. For example, if you look at this program, where I have taken that nested if loop but without any names, and I have used the cycle statement in between in the same example where I have used here without the naming, I have used the without name the nested loop with the cycle operation. Then I am again taking the product of the 2 I and j, then the result will be executed here. So if the inner loop counter j is equal to 2, then the cycle statement will be executed, which will cause the remainder of the code block of the innermost do loop to be skipped. So that whenever j is equal to 2, the further statements will be skipped. So the execution of the innermost loop will start over with the incremented value of j by 1. So the resulting outputs are given in here, where I have taken for the first value, the value of j is equal to 2 is skipped here, so directly it goes to the value 3, and then after reaching the maximum value, again the I value is incremented 1, again the cycle is repeating. So whenever j is equal to 2, again the value will be skipped, then the writing process will be skipped, then the remaining operation will be executed. So like a cycle statement, it is also use the exit statement for the corresponding operation, for the corresponding operation. So it is also possible to make the cycle or exit statement refer to the outer loop also. Suppose here you can say that without naming, so if you use the cycle statement, then always the cycle statement will goes to the innermost do loop. Suppose if you want to specify the corresponding outermost loop or outer do loop to the cycle or exit statement, you can do that, which is possible. Suppose I can do this with this example where I have used the named nested loops with the corresponding cycle statement. The same example with the named do loops with the cycle statement, where when the inner loop counts j is equal to 2, then the cycle outer statement will be executed. So cycle will actually sending the control to the outer do loop, so that the increment of I will be executed in this program. So the corresponding so that the code block of the do loop will be skipped when it reaches the outer do loop. So the corresponding output values are given here. That means 1 into 1 is equal to 1, and the corresponding product. And whenever it reaches the I equal to 2, it reaches to the cycle to the outer do loop, so that the outer loop will be incremented by 1. So again, the I value is 2, j value is 1 comes here, then the corresponding the product and this arithmetic operation will execute it. Again, whenever j is equal to 2, again it takes the control to the outermost loop, so that the corresponding output is this, where the I is actually incremented for 1, 2, 3, and j is printed only for the first value, because second value will be skipped. So you should always use the names with cycles and exit statements in the nested loops to make sure that the statement affect the proper loop. Otherwise, suppose if you are not giving the names, then the innermost loop will be executed. The cycle statement will be executed only for the innermost loop. So we can conclude the do loops construct with one more example, where I am going to find out where I have have the problem here. So you have to write the program for this problem. The problem is as follows. A ball is thrown into the air from any point of the Earth's surface, which will follow a parabolic flight. Suppose if you take any projectile, and if you throw the ball in a x direction or any direction with some angle with the initial velocity, then this ball will have a parabolic like plot. Based on the angle theta and velocity, it reaches a different range and different heights. This projectile program is already known to you. So assume the ball is initially thrown from the position x equal to x0, y0, that means x equal to 0 and y equal to 0 with initial velocity of 20 meters per second with different angles. So with initial angle, you can vary the initial angle. So you have to write the program to determine the horizontal distance traveled by the ball from the time it was thrown until it touches the ground again. The program should calculate the distance for all the angles from theta is 0 from 90 with the increment of every 1 degree. You have to determine the angle theta that makes the range of the maximum range of the ball. So this is the formula you have to use, and you have to find out the corresponding projectile, the projectiles, the angle in the range based on the theta values. So you know the minus 2 v0 square divided by g cos theta into sin theta is the corresponding equation. Here the v0 is the initial velocity, g is the gravitational constant, and theta is the corresponding angle. Okay, so if you substitute all these values, you can get the range corresponding to the particular theta value. So this is the program to implement the corresponding problem, where I have included the constant values. So here you can see that the value of theta is given in degrees. They have to convert this degrees into radians, because the intrinsic functions, the intrinsic trigonometric functions will take the radians value and then it calculates the corresponding theta value in terms of radians. So that you have to give the pi by 180. So I have just taken the value as this value pi by 180 and then take it as another variable degree to radians conversion, and then I have taken the g is equal to minus 9.81 because it's having one more sign here, minus sign here, so that you get the positive value. And I have some different variables with the initialized values. Some of them are real or some of them are integer. And I have another command which is not encountered before. I will let you know what is this now after some time. I just open the file with the file name projectile.dat data file with the label of 1. So I am going to vary that value of theta from 0 to 90 for every 1 degree, and I am going to find out what is the range. Before that, I am going to consider converting this theta value into radians with the real theta into the degree radians, because the theta value is given as an integer. So you have to convert this theta value into real value for multiplying with the real value to avoid the mixed mode operations, arithmetic operations, and then you can calculate the range with the formula minus 2 v0 squared divided by g into sin theta into cos theta. So once you calculated the value of range, then you can just print the values, and you can also find out the maximum. Suppose if you have a series of values, suppose 90 is the values range values from 0 to 90 for different angles, you will get different range values. So to find out the maximum value of the range, you have a different algorithm. So I have just finding out first I have initialized the max range is 0. The value of max range is 0. So I am going to check the range value is greater than maximum 0. If it is true, then the max range will be transferred. The range value convert the range value of range is actually transferred to the max range. Then the corresponding degree will be transferred to the max degree. So this only true. So for using this loop, you can easily calculate the maximum value of the corresponding value in the range. Then you can just print the values, and this is the output here. So it is actually having a long value, the list of data from the theta is 0 from 90, and using the part of the output where the theta is runs from 70 to 90. So for every degrees, it actually incremented by 1, and for every incremented value, you have calculated the range using the formula. And you can see that once the theta is actually reducing, increasing, then the value is decreased. But before this, when it is actually you are going from 0 to 45 and 45 to 90, you have a different paths, the different ranges. That range is actually printed here, where you have varying the value of theta, and you can calculate in the range. So you can see this. The maximum range of 40.77 meters is actually reached when the degree is 45. You already know that when the projectile is projected in the space with the 45-degree angle will reach the maximum value. So you can see this the corresponding 45 degrees here, which is actually having the maximum value. The maximum value before that, each and other angles will have a less range. So this program will actually execute, calculate the corresponding range of the projectile, and it specify the range. Here I have plotted the three different initial velocities. This is for 20 degree and 25 degree, 25 velocity is 25 meters per second, 20 meters per second, 25 meters per 25, and 30 meters per second. So each time if you increase the velocity, initial velocity, the range will be, the maximum range will be high. So this is the program where you have used the end loop to increment the theta value by every single degree. You can also mention the corresponding increment value, and then you can calculate the corresponding values here. Okay, that's all. So we have almost completed the first unit, and the plotting of this GNU plot, the plotting program, the plotting part I will take it in the after completing the second unit, so that we can after completing the Fortran basics, then we can go for the plotting. Okay, that's all. And suppose if you have any doubts, then you can we can discuss it in the online class. Thank you.